Everything on the Minecraft server was normal. The cows were mooing, people were mining, everything was just like normal. I had admins that I trusted, and I thought everything was under control. But then, one of those trusted admins realized they had operator permissions. Oh yeah, man. Can't believe I got these admin privileges. I'm gonna do so much with this. Alright, let me go in here. Let me give myself diamonds. Yeah, let me give myself a whole stack of diamonds. Yeah, should have never gave me those privileges. Why don't I just give myself creative mode? Yep, creative mode. I can fly around. This is freaking sick. Oh, heck yeah. What next? What next? Let me give operator privileges to my buddy, test player. Oh, there you go. Spread the power around. Actually, I don't really want test player to be around anymore. He's getting banned. Boom, banned. Yeah, I think this power's kind of getting in my head. This is exactly what could happen if you give admin privileges to the wrong person. You just saw what just happened, and it wasn't good. At first, this kind of activity can look like normal admin work, because the user technically had permission to do it. But from a digital forensics perspective, the real question is, who did what, when did they do it, and can we prove it from the logs? And that is where BlockWatch comes in.
1, 2, 3, jump!
Now, to take a look at our GitHub repo, I'll try to keep it organized around what the assignment asked for. First, let's look at the source folder. This source folder contains the actual source code. The main file is main.py, and that's where most of the scanner logic is. And then the AI part of the project is separated into the AI ChatGPT analyzer.py. So the open API key or feature is not mixed directly into every part of the main scanner. Moving on to the data folder, it just has pretty much a sample log, and then the real logs for testing, you can just put it straight in there. The docs folder, it's where the final report, test results, screenshots, and other documentation go. I'm still waiting to put the final report in there, and then requirements, it's just OpenAI. It's the only requirement you really need. And then git ignore. This is important because it keeps things like .env, output folders, and Python cache files from getting committed. Taking a closer look here at our main.py file. At the top here, I import the libraries used for file paths, hashing, command line arguments, CSV output, regular expressions, and timestamps. And then I also try to import the AI analyzer, and then if that import fails, the program sets it to none, so the main scanner can still run without AI. Next up here, the suspicious commands. This list contains the suspicious Minecraft activity that BlockWatch looks for. It includes slash commands like /give, /op, /game mode, /ban, and /tp. But it also includes the real Minecraft log phrases like gave, set own game mode, teleported, and server operator. This is important because real Minecraft logs don't always show the commands exactly how they were typed, which is an issue we ran into. Next is calculate file hash. This function calculates a SHA-256 hash of the log file. This matters for forensics because it helps prove the evidence file was not changed after it was collected or analyzed. Next is the classify risk function. This function assigns a basic risk level to each suspicious event. Permission changes and bans are treated as high risk, and then actions like giving items, changing game mode, or teleporting are medium risk. Next is timestamp, extract timestamp, and extract actor. These functions pull up the timestamp and actor from each log entry. This helps the report answer two key forensic questions. When did it happen, and then who did it? Next is scan log file. This is the main scanning function. It reads the log line by line, checks for suspicious commands or phrases, saves each flagged event with the line number, timestamp, actor, risk level, and original log entry. The original log entry is kept because that is the actual evidence. And then write incident timeline and then generate report. These functions generate the final outputs. The text report includes the evidence hash, command summary, risk summary, incident timeline, flagged events, and optional AI analysis. And then the CSV timeline gives the same events in a structured format that can be opened in Excel. And then the bottom here, arg parse lets me control the tool from inside PowerShell, so that you can choose you can choose the log file with log, or you can choose the output file with output, and then disable AI with no AI. And then that's pretty much it for the main file. Next, let's take a look at our AI ChatGPT analyzer.py file. The purpose of this file is to handle the optional AI assisted analysis, and I made sure to separate it from the main scanner so that the core tool can still be able to be used without AI having to be used. And then as far as handling the API key, the API key is loaded from an environment variable called OpenAI key. OpenAI API key, this means that the key is not stored in the code or committed to GitHub. And then if the OpenAI package is missing or the API key is not set, the function returns a message saying AI analysis was skipped or unavailable. And this keeps the tool from crashing. And then prompt and AI output. The prompt asks ChatGPT to analyze one suspicious Minecraft log from a forensic point of view. It asks for risk level, why the event matters, and what evidence to be reviewed next. And the AI output is added to the report, but the original log entry remains the real evidence. All right, now to get a look at the tool in action, I'm going to be running BlockWatch first without AI, just to show that the core forensic scanner works on its own. I'm using a real Minecraft server log here that I generated from my local server. And then this log option tells the tool which log file to scan. And then the output option tells it where to put it, the output, and then the no AI option disables the OpenAI analysis. And then now we run it. And then here's the output. Here we can see that BlockWatch scanned the evidence file, calculated the SHA-256 hash, detected suspicious events, and generated the output files. The terminal gives a quick preview of the flagged events, including the line number, timestamp, risk level, detected phrase, actor, and original log entry. And then now to look at the actual report that it generated, I'll be going to Notepad. And then here, this is the main suspicious activity report. At the top, it shows when the report was generated, the evidence file that was scanned, and the SHA-256 hash. The hash is important because it helps verify that the evidence file has not been changed. And then the command summary here shows what suspicious actions were detected and how often they appeared. And then the risk summary breaks those events down into high, medium, and low risk so that the investigator can quickly prioritize what matters most. And then incident timeline. The incident timeline is one of the most useful parts of the report. It puts the suspicious activity in order and shows the timestamp, actor, risk level, and then the event type. This helps answer the basic forensic question, who did what, and then when did they do it. And scrolling down here to flagged events. The flagged events section gives more detail. So overall, it includes the line number, timestamp, actor, command, or phrase detected, risk level, and then the original log entry. I kept the original log line in the report because that's what the actual evidence is. And then going back here, I'll open the CSV report. So here's our CSV file. Um, This CSV file just kind of makes the results easier to reuse in Excel or a report or any other analysis tool. So then even without AI, BlockWatch is already performing the core forensics workflow. It scans logs, preserves evidence integrity, identifies suspicious activity, reconstructs a timeline, and then it generates reports. All right, now I'm going to be doing the AI demonstration. So I'm going to be running the same Minecraft log file that I did before, and then just do it with AI analysis enabled. The important part here is the scanner still does the detection first. The AI just only gets involved after an event has been flagged. So we're going to run it. It's going to give us all the same stuff we got before, but now it's prompting the AI, and then it's going to load. And so now that the AI has been prompted, the report is made. So we're going to take a look at the report that it generated. So we can see that it's pretty much the same as the previous report that was made without the AI, but now we scroll down and we see this, which is our AI assisted analysis. The AI just basically gives a short explanation of why the event might matter in an insider threat investigation, and then it gives some recommended follow-up evidence to review. For an example, here it says server operator. So an event involving operator permissions or banning a player can be important because it shows possible misuse of administrative power. And AI helps kind of explain that context, but it's not replacing the evidence. It's just kind of giving a better explanation of it. So the evidence is still the original log entry and the timestamp, actor, risk level, and SHA-256 hash. The AI is just here to help with triage and explanation. Overall, BlockWatch worked the way I wanted it to. You could scan both sample logs and real Minecraft server logs. It detects suspicious admin activity, assigns risk levels, extracts timestamps and actors, calculates a SHA-256 hash, reconstructs a timeline, and it generates both a text report and a CSV timeline. One of the biggest things I learned was that the real log data doesn't always look like sample data. At first, the tool was mostly looking for slash commands like /give or /op, but real Minecraft logs use phrases like gave, set own game mode, teleported, and server operator. Updating the scanner to support both formats made the project much more realistic. I also learned that AI should support the investigation, but it shouldn't replace it. In this project, the AI helps explain suspicious events, but the real forensic evidence is still a log file, the hash, timestamp, actor, and generated report. There's still a couple things I can improve on, like scanning the entire log folders, supporting plugins like Core Protect, improving target extraction, and adding a visual dashboard. But for this project, BlockWatch demonstrates the main forensic workflow, which preserve evidence, detect suspicious behavior, reconstruct a timeline, and generate a report. And thank you for watching.